The industry standard for adding grounds to existing receptacles involves using a grounding electrode conductor, also called GEC, connected to a suitable grounding electrode. This electrode can be a water pipe, a ground rod, or a UFO ground. Typically, the GEC is a number 6 or number 8 American wire gauge, abbreviated AWG, bare copper conductor. It runs throughout the structure and connects to the grounding terminals of electrical panels and other equipment. Using a number 6 AWG bare copper wire around the basement as a GEC is generally acceptable if it meets certain requirements. Firstly, it must be properly bonded to the grounding electrode. Secondly, it needs to be sized appropriately for the largest feeder circuit in the structure. Thirdly, its routing should protect it from physical damage. Running number 12 THHN from the number 6 AWG GEC to each receptacle is acceptable. However, using a split bulb connector isn't advisable because it may create a higher resistance connection. Instead, consider using an approved ground bar or wire nut. Enclosing the number 12 THHN in conduit within the walls is a good practice for protection from damage. Tagging the connection point between the number 6 AWG GEC and the number 12 THHN is a good practice. It alerts future personnel to the importance of the connection. For increased efficiency, firstly, consider using a fish tape or pull string to help with fishing the number 12 THHN through the walls. Secondly, use pre-assembled grounding bars to simplify and speed up the connection process. Thirdly, if the walls are open, you may be able to run the number 12 THHN and conduit along the top or bottom of the studs. This eliminates the need for fishing. Ensure that all existing receptacles are grounded properly. Always consult with a licensed electrician before performing any electrical work to ensure compliance with local codes and safety regulations. The grounding electrode conductor, or GEC, plays a critical role in providing a safe path for fault current to return to the source. This path is essential for the proper operation of overcurrent protection devices like circuit breakers and fuses. These devices are designed to quickly interrupt the flow of electricity in the event of a fault. This prevents electrical shock and minimizes the risk of fire. When selecting a grounding electrode, consider the soil conditions and local codes. Ground rods should be driven deep enough to reach permanently moist soil. Water pipes used as grounding electrodes must be metallic and have continuous electrical contact with the earth. UFO grounds, which are concrete encased electrodes, are often the most effective grounding method, especially in areas with poor soil conductivity. The size of the grounding electrode conductor, or GEC, is determined by the size of the service entrance conductors. The National Electrical Code, or NEC, provides tables that specify the minimum size of the GEC based on the size of the service entrance conductors. It is crucial to adhere to these requirements to ensure the grounding system can handle the maximum fault current. When connecting the GEC to the grounding electrode, use approved connectors and method. These connections must be mechanically sound and electrically conductive. Avoid using methods that could corrode or loosen over time. Regular inspection and maintenance of the grounding system are essential to ensure its continued effectiveness. Check for signs of corrosion, loose connections, and physical damage. Address any issues promptly to maintain a safe and reliable electrical system. In older homes, grounding systems may not be present or may not meet current code requirements. In these cases, it is essential to upgrade the grounding system to provide adequate protection. This may involve installing a new grounding electrode, running a new GEC, and ensuring all receptacles and equipment are properly grounded. When adding grounds to existing receptacles, it is important to identify the wiring method used in the home. If the wiring is non-metallic sheathed cable, commonly known as Romex, it may be possible to run a separate grounding conductor from each receptacle back to the grounding electrode. If the wiring is armored cable or metal conduit, the metal enclosure can serve as the grounding path, provided it is properly connected to the grounding electrode. In some cases, it may be necessary to install a new circuit with a dedicated grounding conductor to serve the receptacles. This is often the best option when the existing wiring is inadequate or unsafe. When fishing wires through walls, use appropriate tools and techniques to avoid damaging the wiring or the wall. Fish tape, wire loop, and flexible drill bits can be helpful in navigating tight spaces and avoiding obstructions. Always de-energize the circuit before working on any electrical wiring. Use a voltage tester to verify that the circuit is off before touching any wires. Wear appropriate personal protective equipment, including safety glasses and gloves, to protect yourself from electrical hazards. When making connections, use approved connectors and methods. Wire nuts, crimp connectors, and terminal strips are commonly used for making electrical connections. Ensure that the connections are tight and secure to prevent loose connections and overheating. Label all circuits and connections clearly to facilitate future maintenance and troubleshooting. Use a permanent marker or label maker to create clear and legible labels. Keep accurate records of all electrical work performed, including wiring diagrams and equipment specifications. This information can be helpful for future repairs and upgrades. Consider using surge protection devices to protect sensitive electronic equipment from voltage spikes and surges. Surge protectors can be installed at the service entrance or at individual receptacles. Educate yourself about electrical safety and the National Electrical Code, or NEC. Understanding these principles can help you to identify and avoid electrical hazards. If you are not comfortable performing electrical work, hire a qualified electrician. Electrical work can be dangerous and should only be performed by those with the necessary skills and experience. When working with electrical panels, be aware of the potential for arc flash. Arc flash is a dangerous electrical explosion that can cause serious burns and other injuries. Wear appropriate arc flash protection when working on energized electrical panels. Follow all lockout-tagout procedures to prevent accidental energization of circuits during maintenance and repair. Lockout-tagout involves disconnecting the power source and placing a lock and tag on the disconnect switch to prevent it from being turned on. Be aware of the potential for static electricity when working with electronic components. Static electricity can damage sensitive electronic devices. Use appropriate grounding techniques to prevent static discharge. When working with power tools, use ground fault circuit interrupters or GFCIs to protect yourself from electric shock. GFCIs are designed to quickly interrupt the flow of electricity in the event of a ground fault. Dispose of electrical waste properly. Recycle electronic waste and dispose of hazardous materials in accordance with local regulations. Be aware of the potential for electromagnetic interference, or EMI, from electrical equipment. EMI can interfere with the operation of other electronic devices. Use shielded cables and grounding techniques to minimize EMI. When working with high voltage equipment, follow all safety precautions and use appropriate personal protective equipment. High voltage equipment can be deadly and should only be worked on by qualified personnel. Be aware of the potential for electrical fires. Electrical fires can be caused by overloaded circuits, loose connections, and damaged wiring. Install smoke detectors and fire extinguishers to protect yourself from electrical fires. Follow all electrical safety guidelines and regulations to ensure a safe and reliable electrical system. Electrical safety is everyone's responsibility. By taking the necessary precautions, you can protect yourself and others from electrical hazards.